I would like to introduce you to Dr. Colin Murphy, who has graciously agreed to attend tonight and talk to you about all things CK600 and engineering. So Colin, thank you very much for joining us this evening, and I'll hand them over to your capable hands.
Great, thanks Ruth. Welcome everybody. I hope you'll find this hour of use to you. I know your time is precious now. In case I forget at the end of the session, best of luck with your Leaving Cert. And of course, with whatever course you end up doing, I hope you'll find it stimulating and enriching for your future, not just financially, but that it makes you happy. That would be my hope for you. So what I'll do is I'll share my screen, hopefully if this works. Okay, so I'll just switch over now to a short presentation. Can everybody see that?
Yeah, that's up.
Okay. Great. Okay, so Colin Murphy is my name. I'm in charge of coordinating the first year students in engineering. And what I hope to do this evening is answer the questions that have come in previously, and then hopefully answer as many as I can on the fly. And we'll see how we get on. If there are questions I don't know the answer to, I'll try to follow up with Ruth and maybe get the answers back to you in jig time, if you like, as quickly as possible. So a common question in the previously kind of inputted questions was, what modules will I study if I do engineering in first year in UCC? So I've taken the slides from this current engineering class when I met them in September, just showing them the modules and the lecturing hours that they would be involved in, and the dates associated with those. So you can see here their exam session was in December, and if you do engineering, that would be the case for you as well, barring any COVID related issues. We try to get those first semester exams done in December. So the first semester is foundational, and we have some kind of scientific topics really. So chemistry will have 2 hours lecturing a week. Engineering, computation and problem solving is given by a lecturer in the School of Engineering rather than in the science faculty. So that's coding. The physics for engineers 1, which is a 10 credit module, will have 4 hours a week. Most modules are 5 credit modules with 2 hours of lectures a week. And then there's some mathematics, which is 3 hours a week, and engineering thermodynamics is the second engineering module taught by one of my colleagues in this department. I'm in electrical engineering myself, so he'll do 2 hours teaching a week. So associated with those modules, there are labs and assignments. So it varies from module to module, and I'll show you when we're looking at what's called the book of modules, how to determine what the continuous assessment items are for a particular module, so you can kind of self-educate, if you like, what's involved on the continuous assessment and practical side. One of the questions that was asked was, do students work in teams? And the answer is yes. On many occasions they do. Teams of 2 up to maybe 5 or 6 students. And the reason for that is, as you'll see as I go through this, engineering is usually a multidisciplinary activity when you work in industry, and to work well with others is a prerequisite really. So we work on the development of those people skills right from first year. After Christmas then, in semester 2 we call it, starting in January, so that was the 17th of January this year, the following 6 modules as shown would have been studied by the students in semester 2. So there's some more physics and maths, and then we have the 4 engineering specific introductory modules, 1 for each of the programs that we offer. So the electrical engineering one, Introduction to Electrical and Electronic, I teach 50% of that myself. Then we have a civil engineering one, we have an energy engineering and process engineering module. So the concept, if you like, behind the design of the program is that you have the opportunity to explore each of the 4 programs in an introductory module setting, and that should inform your decision as to what your top 2 choices are for a degree program to actually graduate from in due course. So we think that's a positive addition to the design of the engineering school's educational offering. It's relatively new, it's only been going on for a few years, And we get a lot of positive feedback from the students that they find those introductory modules very revealing in terms of enabling them to make an informed decision as to what they like and what they don't like. And again, the same story with those. There'll be project work and laboratory work, there'll be in-class tests, lots of continuous assessment. And for example, in the introduction to electrical and electronic engineering, 50% of the module is related to continuous assessment and 50% to the final exam. So it's well balanced, if you like, in that sense between practice and theory. Now, a question that arises often is, if I'm in the course and in the first 2 or 3 weeks, I find this isn't for me, am I stuck? And the answer is not necessarily. So a change of course application can be made usually in the first 2 to 3 weeks from the start of the academic year. If you wish to apply to move to another program in UCC, as you would expect, you must have the points required for the entry to the course to which you wish to transfer. You need to satisfy the minimum entry requirements for that program, and there must be a place available. So for example, if you were trying to transfer to medicine and chemistry is a prerequisite for medicine and you didn't have it, then you would not be considered. But in the event that you did and you had the points and there was a place available, then you could potentially transfer across to medicine. So it's important to know, if you like, that UCC has that facility for you. And what we find is generally maybe 2 or 3 students decide engineering isn't for them and they leave, but similarly 2 or 3 come in from other programs because they want engineering after the first 2 or 3 weeks in the program they actually signed up for. So we tend to be neutral, if you like, in the change in numbers. A few go and roughly the same number come from other courses as well. So how does choosing the degree program work after you've done your examinations at the end of first year with us? So I'll just switch across to another app for this. Just 1 second now. Okay, so if we start the program allocation process, the question we would ask you in semester 2, which is in between January and I suppose the end of April, really, to state your first and second program preferences. So when you're about 8 weeks into your introductory modules for each of the 4 programs, we ask you to state your first and second preferences. So you might say energy engineering is the one you like the most, and maybe process and chemical is your second choice. So then we'll check if you completed your first engineering summer exams in your first year of registration. So let's say you passed all your exams in the summer, you've passed all your exams in the winter sitting for semester 1. So you're good to go, if you like. And so yes is the answer to that. In the event that no is the answer, then you'll have to repeat failed modules, and I'll talk about that shortly. But hoping that everything went well for you and you've passed everything, then places will be assigned by merit based on your overall aggregate mark. So because you've done 11 modules, remember physics was a 10-credit module and the others are 5-credit modules. So if you've passed all of those, we add up all your marks in the individual exams, and then we rank the students according to the total mark, and then we start assigning places based on their first preference. So each of the programs, electrical, civil, and energy, have a quota of 40 students each. And this year, process and chemical engineering have increased their quota to 45 students. So we'll be looking to fill as many places as we can, obviously, from the rank ordered list according to people's first preferences until a program is full. And then if the program is full, subsequent applicants for that program would have to take their second choice. So we guarantee you one of your top 2 choices, but not necessarily your top choice. And the reason we can't do that is quota related. So in the event that, for example, civil and environmental had 120 students want to do it, their department isn't big enough to cope with a class group that size. And so the quota system has to kick in. So the reason process and chemical have increased to 45 is due to demand. In the last few years, the demand for process and chemical has been the highest. And so they've increased their resources to try and accommodate that additional demand. So then once you've been assigned your place and hopefully accepted it, you would transition then smoothly into second year. So that's the route, if you like, that most students will take because most students do get through the exams in the first sitting. But in the event that you need to repeat 1 or more modules, then we go across to the autumns, they're called, and you'll do autumn repeats. So let's say you failed 2 modules. If you repeat those and pass them both, then you go into the allocation mechanism again. In the event that you fail one or more, you would have to stay back in first year and repeat failed modules. So hopefully that won't happen. It does happen generally to 1 or 2 per year, and such is life, but hopefully it won't happen next year. So then if you've passed your autumn repeats, the remaining places are assigned by merit based on overall aggregate mark again, but there is an important difference. And the difference is that the modules that you are repeating, the mark that you score in those is capped at 40 for the purposes of calculating your overall aggregate mark. So what that means is when you repeat the module, let's say you scored 67, to go into the merit order, only 40 will be put in for you. So everybody who passes their modules, they're capped at 40. And the idea behind that is so that you can't defer to the autumn and see that as an advantage, because that would be unfair. So if you pass it, 40 will be put in for you, and then the sorting will be done. And if you don't pass it, you'll have to repeat that module or modules in first year again. So then the remaining places, if any, are assigned based on overall aggregate mark, and we do ensure that you get either your first or your second choice. So, for example, in the event that, I've forgotten to swap those two, so this is wrong, sorry. The process and chemical should be 45 and the energy should be 40. My apologies, I changed that earlier on the previous drawing, but not this one. So in the event that, let's say, for example, civil and environmental, although they nominally have a quota of 40, because we guarantee we'll give you at least your second choice, civil, elec, and process and chemical and energy have agreed that students will be taken in if at all possible, and electrical, civil, and energy certainly have the capacity to take more than 40. So you won't be stuck where you're not getting your second choice. That's a guarantee. So that's how the process works. And then once you've been assigned your program, you enter second year. So hopefully that's reasonably clear. And that, I suppose, drawing is now in the recording if you want to have a look at it again later. So if I go back now to my few slides, that's how choosing the degree program works. And generally it seems to work well for most people. The one program that has been oversubscribed is process and chemical in recent years. So we have seen a few students who wanted it not get it, of the order of maybe 4 or 5. And then this year, I think there's been about 7 or 8 students over the quota of 45 who've expressed it as their first preference. So there will be some who will be getting their second preference in that case. But the other programs don't have that oversubscription issue. And so unless something very unusual happens next year, if you want one of the other 3 programs as your first choice, you're very likely to get it based on recent experience. So a question that arises then is, should you do the bachelor's in engineering, the BE, or the master's in engineering? So the master's is an extra year, which is year 5 of study. And a question that arises is, what are the advantages of doing a master's in engineering? So to qualify for doing the master's, you must score an average of at least 50% in your 3rd year engineering exams in whichever program you're in, because the ME is the same design for all 4 programs. The advantages of it are, once you've gained relevant experience in industry, and that would normally be a few years, depending on the experience you're gaining, could be somewhere from 2 to 5 years. With that experience under your belt, if you like, you then have the full academic credentials to become a chartered engineer through Engineers Ireland. So that's the advantage of the ME. In the event that you're doing processing chemical, you also have full membership of the chemical engineers MI Chemie. So the masters would be required for that. Now, one thing to know about the status of chartered engineer is it's generally required in civil engineering. It's a positive in processing chemical, but in electrical engineering, unless you want to work in the electrical side rather than the electronic side, it tends not to be important to employers. A lot of our graduates are never chartered engineers. They work as electronic engineers without that requirement. So you could do the master's to have an additional qualification to strengthen your CV. But if you were doing electrical and electronic engineering and you wanted to be an electronic engineer, you'd probably find that the chartered engineering status is not something that employers are asking you for. And I don't know about the energy engineers actually. I'm not sure whether it's important for them or not. It might be. So the ME program, you don't decide until you're in third year. And if you've scored at least an average of 50%, you're eligible to apply for it and transition into it. The other advantage is if you're doing a master's in any other way, it's usually a 2-year program, and that's twice the fees. Whereas this way, it's a 1-year add-on, and obviously that's half, just an additional year. So it's a very cost-effective way and a time-efficient way to get that master's on your CV if you would like that. In terms of how many students do the master's, it depends on the program. For electrical and electronic, we're finding about half the class do the ME. In contrast to that, with process and chemical, it's about 85% of the class do the ME. So it seems to be very much dependent on the program and I guess the employer's view of the ME when you subsequently go out into industry. So an interesting fact for you, thankfully you all have engineering on your CAO. This is something that you might not be aware of. A survey was done by Spears Wealth Management magazine some years ago, and they surveyed 70,000 millionaires with one question: what's your primary degree? The majority answered engineering. And the same is true of the world's billionaires, that amongst that cohort, the most popular primary degree is engineering. So if engineering is of interest to you, and hopefully it is, then there's lots of scope and potential there for financial reward, and that has been proven, if you like, by at least 70,000 millionaires and a collection of billionaires as well. Okay, so where do graduates go when they've finished their education and sort of training with us? So I'll just have a look now at some of the recent surveys done by UCC. So this is a graduate outcome survey from 2018, and this is for the energy engineering program. There were 12 respondents in the survey. The class size was quite small at the time, but they had 100% employment in that case. So that's, I suppose, although a small cohort, the placement percentage is very high. If you look at the previous year, half the class went to work and 40% stayed on to do further study, while 7% were not available for employment or study for, maybe they were taking a year off, I don't know. If we look to process and chemical engineering, so their employment in 2020, almost all of the class, 97% went into employment and 3% were seeking employment. So there was a class size of 41 there and 76% responded. So of those who responded, 29 of the 30 were in employment. So that seems to be the most popular destination for graduates of process and chemical, certainly in 2020. And if you look back at the previous years, that was maintained as well. They tend to go out to industry rather than doing further study. In terms of electrical and electronic engineering, it's, I suppose, a bit different. In 2020, most of the class were in employment. We had 8% in further study and 8% seeking employment. But generally, if you look back at previous years, it would be about a third of the class or half the class in employment, and then a fairly sizable proportion in further study or training. So that's quite common in electrical engineering. Quite a few students would stay on to do masters and PhDs, just I suppose because they enjoy it and the opportunity and the funding and the support to do it is there. So that is quite common, I suppose. And I've been lucky to supervise PhD students in my own area over the years. So there's a healthy postgraduate activity, if you like, in electrical engineering. And then finally, if we go to civil, in 2020, 72% employed, 14% in further study, 14 seeking employment, and none unavailable. So they're recent overviews of the destinations of our graduates. And I suppose the underlying message is in recent times, the demand for engineers has been thankfully very good, very strong. Generally, we hear that students have more than one job offer, so that's a nice position to be in. Now, nobody can guarantee you that in 4 or 5 years' time that will still be true, because who knows what will happen. But one of the nice things about engineering is it gives you a very flexible and broad base of skills and knowledge upon which to build a career. So you can adapt in the event of kind of turmoil in the market. You have lots to offer employers, and usually you can pivot, is a word that's sometimes used. in another direction and still find, a job that enriches and fulfills you. Okay, so that's graduate destinations. So if I come back now to preview, this is a useful link, so I'll take it. So looking at the calendar for engineering, what you'll see is the 4 programs. First of all, starting with the entry into first year, if you click on that link, the information relating to first year, it's general, and then specific modules, which I've mentioned earlier. You can have a look at that. What I wanted to draw your attention to was this: the module descriptions can be found here. So if we click on that link, you have the opportunity now to enter a specific module code and learn about that module. What can be particularly helpful is to search based on prefix. So if I search for my own area, which is electrical engineering, our prefix is EE, and there are 61 modules in electrical engineering taught by the electrical engineers. And then you can drill down to any particular one that you're interested in. So the first year module is this one, and then the description pops up and you can have a look. And as I mentioned, you can have a look at the assessment, and you can see in this case, as I mentioned, there's 50 marks for the written exam, and there's 50 marks for the continuous assessment, which is a project. So for any module that you're interested in, the book of modules will give you the information that you need in order to determine what that module is about. And then the specific learning outcomes are listed there if you wanted to have a look at those as well. So if I just go back there now, the book of modules then is the key, if you like, to decrypting what all of these mean in terms of what they're about and how they're assessed. So you can drill down then in your own time in order to explore further what's going on in each of those. The entry to second year then, since we're still on a first year page, the quotas, this will be updated to 45. So there's a kind of a general description there. And then if you go back to the previous page, you having decided, for example, that you might like to do energy engineering, if you click on that one, you'll see you can drill down into second year, and then you can go to the modules, or say you might like to see what is CE2004 about. If you just go into the module descriptions and type it in, CE2004, and search for that, you can then drill down and have a look at it. And there it is. So it's called Fluids 2, and so on. So that link, I think, is the key, along with the book of modules, to opening up a map for the way the programs evolve. And you can go as far as 5th year. So in the case of energy engineering, you can have a look at what the modules in energy engineering are. And here's one, for example, in 5th year. This is an optional module on optimization from the computer science department. There's an optional module on management and practice from the management department. So in the 5th year of the ME, some of the programs have modules coming from other disciplines in the university, not from engineering. So that can be of interest then to some students to look, I suppose, at broadening out their educational base in 5th year. Okay, so that link then is it's up here. So that's in the preview there, this PDF. So I would recommend that you dig around and educate yourself as to how this engineering program is laid out and what the individual modules involve, or what's involved in those. Okay, so the remaining questions then that Ruth gave me, I have on another window here. And some of them now at this stage we've answered. So what can I expect in first year? Hopefully I've given you an overview of that. Are there further study options, and where do graduates go? We've answered the graduates go. Further study options, yes. So just to bring your attention to these 3 research centres. So UCC is blessed with the Centre for Marine and Renewable Energy, the Tyndall National Institute, and the Environmental Research Institute. And as you can see, they're fairly substantial investments. Those are significant buildings housing, in the case of Marai and Tyndall, up to, well, Tyndall have more than a couple of hundred, and Marai probably of the order of 100 or so. The ERI probably less than 100, I'm not sure exactly, but there's loads of opportunities for masters and PhDs in those 3 research centres. They're very well funded, well staffed, and well recognised internationally. So that's useful to know. And you'll have seen that in the process and chemical case, nearly all the students go to work. They don't stay on for study. But the head of the program, Professor Ed Byrne, told me that in the event that students do want to do a PhD or a master's, there is funding available and there is opportunities to support them. So that is there as well if you were interested in it. Okay, the next question is one I can't answer, I'm afraid. Is there a future for nuclear power, and why aren't there grants for anaerobic digesters? I have no idea. I'm sorry, I can't help with that. We've seen the course modules and how to drill down using the book of modules to understand maybe a little deeper what's involved. The careers areas, I suppose, largely civil and environmental engineers work on the built environment. Smart cities would be a hot topic for them. Building of roads and buildings and so on. Electrical and electronic engineers, as the name suggests, would be involved in power distribution and renewable energies, and also the design of electronic circuits and systems like chips for laptops and phones and computers and so on. Process and chemical engineers tend to work on process design and running processes in chemical factories often. For the likes of producing medical products, tablets, and so on. And then the energy engineers are like a hybrid of civil and electrical engineers in that they're interested in renewable energies and how to bring those to the benefit of society, I suppose. Are there R&D opportunities? I've just mentioned that below with the 3 photographs. Module breakdown, what they consist of and how it works. Hopefully I've answered those questions now. How much work is expected from us? Will there be projects? If so, how many? And do they have to be done in groups? So engineering is what we call an immersive degree program. You are expected to engage fully with it and work hard on it. Generally in teams with project work, there are some assignments that you do on your own, but to be honest, the majority of the work tends to be in small groups. How many approximately? Well, each module has its own design, but you can drill down and have a look. And as we saw in the case of the electrical module, there is a project. So you could have a look yourself to see if a particular module has a project or not. So how many spaces are there in each discipline? We've seen that. Is it possible to not get your desired one? Yes, but you're guaranteed your second choice no matter what. The workplace and working environment, very broad, I'm afraid, with 4 different programs. I guess all I can say about that is engineers generally tend to enjoy good quality employment with good employers who pay them well and give them good terms and conditions. So I suppose the qualification is valued and respected, and the rewards in terms of not only money, but the working environment are usually good. So there's not usually a problem there. Is the course difficult, and how competitive is it to get into chemical engineering? So yes, engineering is a challenging program, but if you engage with it and try your best and work with the teachers, the academics and the postgrads who are demonstrating, you should be fine. The competition to get into chemical engineering at the moment is the highest, and about 52 have said they wanted first for 45 places. The total class size is typically of the order of about 135 students. So that might give you an idea of the competitiveness for process and chemical at the moment. How long do I think it'll be until almost everyone's jobs are replaced by machines? I must admit I'm not qualified to answer that. I have no idea. So we'll have to move on. I don't know. What kind of practical work is there throughout the years? Each of the engineering modules generally has plenty of practical work because engineers are practical professionals. And so the continuous assessment might be somewhere from 20% to 50%, or even in some cases 100% of the module. So there's plenty of practical work. What kind of work would you do with electrical and electronic engineering in particular? So in the electrical case, it's usually power distribution, whether it be from renewables or not, working for the likes of ESB or ESB International if it's abroad. And then the renewable energies companies often hire electrical engineers. The electronic engineers tend to work on hardware and software for chip design and software kind of manipulation of those chips. So an example of that might be designing a gadget to work with your home Wi-Fi. Maybe something like the Alexa, for example, would have needed electronic engineers in the design of the hardware for that and the associated software integration. Work placement, so that's an important one. Work placement is a necessary part of the Masters in Engineering in the ME. So you do an 8-month paid work placement. In the case of the Bachelors in Engineering, the BE, work placement is optional. And in the event that you opt to do it, we will help to place you with a company in industry, but you don't have to do it. So generally, the uptake on optional work placement is about 50% of those who could opt for it do, and the others opt for, I suppose, a different way to spend their summer, let's say. Is the 5th year Masters of Engineering accredited by IEI for Chartered Engineer? Yes. So in order to be eligible for the status of Chartered Engineer, you now need to have a basic qualification of a Master's. The BE is no longer sufficient. But as I say, that's not necessarily relevant to all engineers. But you do have to top it up with 3 to 5 years of on-the-job experience before you can apply for the chartered status. If I like computers, which stream should I choose in engineering? Personally, I would suggest electrical and electronic because the products that we work on naturally have both aspects in them. There would be software in other programs as well, but electrical and electronic is the one that is most obvious to me if you liked computers. What sort of laptop or other materials will I need before starting the course? So in terms of laptop, I guess anything that runs the latest version of Windows to your satisfaction would be fine. And no other materials really are required before starting the course. So personally, I'm an Apple Mac user, and in the event that I need to run anything on Windows, I just run the emulator on the Mac. But if you're happy with Windows, then a Windows laptop would be fine. Is there an option to do work experience? So hopefully I've answered that now, that it's optional in the bachelor's program and compulsory in the master's program. What areas in engineering have the highest demand for graduates? I suppose at the moment they're all in maximum demand. So it's a very positive time for our graduates at the moment. I don't think there's any one program that has a higher demand than any other. They're all being hoovered up, if you like, by industry. So it's a very positive time at the moment. Renewable energy engineering, salary and study abroad or work abroad options. So it turns out that energy engineering is getting a huge injection in the EU. About 400 billion euros has been announced recently because of the difficulties with sourcing carbon-based fuels from Russia. And so the EU has decided to invest substantially in renewable energies. So it's a very positive and exciting time for energy engineers over the next few years for that reason. In terms of studying abroad, I'll kick that one to the next. Oh yeah, working abroad. All of the engineering programs are accredited by the Institute of Engineers of Ireland, and we were accredited recently, I suppose about a month ago, for the next 4 years or 5 years maybe. So that enables you to work as a professional engineer in any of, I think it's 103 countries under what's called the Washington Accord. So because the programs are accredited, you're guaranteed that your qualification is not questioned when you work as an engineer abroad. Now, in terms of studying abroad, the Erasmus scheme, if you have an average of 60% in your exams over years 1 and 2, so at the end of year 2, you have to have an average of over 60 across years 1 and 2, then you're eligible to apply for Erasmus, which would allow you to do up to a year in a university, largely in Europe. So the health warning on that is you really would be advised to pick a university that teaches through English, unless you happen to be fluent in another European language and are happy to study in that. And the other thing to say about it is you are parachuting yourself into the middle of another program without having done their years 1 and 2. And you might find that there's a very stiff learning curve in order to perform well. And we have seen that with some of our undergraduates who've gone to, for example, Germany, where they found some of the modules they were doing that didn't really have the background for them, and they were having to scrabble and work really hard to catch up. So whilst a year abroad has a lot of positives, there are risks as well. And you do have to be careful and think it through, I suppose, properly, if you like, rather than rushing into it. Are there possibilities for deferral? I'm not an expert on deferral. I think probably what you would do there is you would go to the, actually, I'm not even sure who you talk to, but yes, deferrals are possible, but it's not a right. So in the event that you'd like a deferral and you're in the program, you go and talk to the head of program, who would then hopefully agree that it's a good thing for you and then take you through the deferral application process.
And
At the end of the day, yeah, please, Ruth, come in.
Just in relation to deferrals, I'm not sure if this question is relation to CAO offers or while you're in the program. So if it's a CAO offer and you want to defer, it's not a guarantee, but if it's for medical reasons or anything like that, or if you just want to take a year out, the advice I'll tell you is to do not accept your CAO offer. If you wish to defer your year, do not accept it and contact our admissions office immediately once you receive the offer, and they'll go through this, the process with you. If it's a case of a deferral in your course, we don't actually call it a deferral. It's what it would be called is more of a leave of absence, unless you're deferring your exams for certain reasons. And as Colin said, you go to your head of program and they'll talk you through the whole entire process. So there'll be someone on hand to help you, whether it's a CAO application or it's during your academic studies.
Great, thanks, Ruth.
Sure.
So what are the electives I can pick up during different years from computer science? So I had a look at that. The electives really only come in fourth year and fifth year. And from computer science in fifth year, we saw in the case of civil, they had an optimization module. And in the case of elect, we have 2 modules related to Python and machine learning. But the other programs don't have computer science specific electives. So they're the 3, if you like, that I saw when I dug down. And I'll come back to software engineering in a minute, actually, because it's the question below the next one. So hopefully that answers that one. Male outlook of females, gender stereotyping. I'm afraid I'm not qualified to answer that. The only thing I can say is I have never once heard negative feedback from any female engineer in relation to their experiences in industry. That's all I can say. Can you branch into software engineering? Generally, people can. You're not a qualified software engineer, but you generally have good skills in terms of IT and competency with logical problem solving. Some electronics graduates do go into software engineering, particularly for companies that are working with hardware and software co-integration. I did have one student who did a project for me and then went on to work for Microsoft as a pure software engineer. So what they did there was they put him on a 6-month probation, and they were happy with him at the end of that, and they hired him as a software engineer. So it can be done, and it's relatively easy to do if there's a hardware software aspect to the job. If it's software only, you won't have done a lot of software modules because it's not a software engineering program, but you will have done some. And some of our students are self-taught. They do a lot of IT related upskilling, if you like, on their own time. And so there's no reason why you can't compete successfully then if you're in that space. The combined master's program, so hopefully I've addressed that. The grade thresholds, you have to have an average of at least 50% at the end of your 3rd year exams to go into the ME program. And in terms of career options, I guess the main thing really is the eligibility for the chartered engineering status. So they're the questions that I was given in advance. And I guess at this stage now, I'll go back to hopefully, if I can find it, yeah, the general session. Okay, so can I throw the floor open maybe to any other questions that you might have?